source, right? It is a data source, and you have media data. So another very kind of important thing which we are also emphasizing is that media data, video right now, if you see, is a separate beast by itself. We would like to integrate video with other data, because a lot of interesting applications emerge when you are able to analyze video in conjunction with other kinds of data. To give you one simple example, I can actually estimate pollution by measuring wind speed and traffic density without actually putting a gas sensor out there or particulate matter sensor. Why? Well, because finally, if major source of pollution is vehicle, then if I know the kind of number of vehicles going and whether they are diesel or petrol, and if I look up the emission inventory record from Department of Transportation, I can make a guess how much they are emitting out, and based on the wind speed measurements, I can use the mathematical models which have been developed by environmental scientists to kind of come up with a prediction. You see, I am putting together completely different, 3 different data sources: wind speed measurement, video analytics, access to database from Department of Transportation, to make a prediction of something completely different. I mean, you are kind of replacing chemical sensor by a virtual sensor. It's just one simple example. There could be many such examples which could emerge in the future if people had access to be able to solve problems, access to these data. That is why video is very important, because video is a rich source of data. So there are 2 sets of APIs: the control API on the left and the data APIs horizontally. And the data exchange platform's role is to actually, one of the goals is to come up with the technical specifications of both sets of API, the vertical API and the horizontal APIs, have it completely open, and all the kind of a schema for reporting the data models. I mean, we can't, the data models itself are very specific to particular data sources. Like a street light will have its own data model, kind of the smart fans will have its own data model, etc. Let the device vendor ecosystem come up with the data models, but there is a template for how the data models should be defined and so on, which is provided by this particular platform. So what this platform really does is it just connects. It's just a connector. I mean, that's why we call it an exchange, right? It's a switch. It connects sources of data, that is both video and other kinds of data, to solutions or applications, and it has to be open APIs. Right? You should not call up a system integrator. What is this? It's all published out on Swagger or any of the standard API publishing mechanisms. SDKs are available. Application developer just looks at it, develops an application. You don't have to talk to anyone else, right? It's just there. Third-party solution providers should be able to develop solutions, and both on the top as well as in the bottom. You have a new, you come up with a new device. You see it's compliant, it's able to connect with the data platform, you are good to go, right? And you are out in play, any city should be able to buy it. Security and privacy should be there as part of by design, and a strong audit framework so that you kind of know what happened, right? Things like data provenance, transaction provenance, etc. And important thing is the owners of the data have the control of the data. That is, they should, using this control plane, they should be able to kind of control, like your Google Drive, right? You have control over your files with whom you share. That's basically the idea. The cities or whoever uses the platform have complete control with whom they share, right? And ideally, you should also be able to track what have they done with your data in the future. So the vision is that this kind of a platform will allow disparate, independently developed city systems to kind of get connected with each other in a seamless and secure way. So you could have in a city the Bangalore Water Supply Board, BMTC, the ICCC of the city itself, the traffic police, etc., all now interconnect. They might have their own solutions. They might have developed the solutions with their vendors, etc., which is fine, but you can just have adapters created which can speak this kind of IUDX API. And that will enable new applications to actually emerge, which can do analytics across silos. As I mentioned, if I had access to traffic video feeds, I can make some comments on the pollution levels. And then you open it up to third-party people, even for the city to kind of figure out, are the SLAs being maintained? What are the KPIs? Can you actually measure the KPIs with your ICCC? Implementation right now, I don't know, but maybe with this kind of approach, you can have startups, etc., come in and provide these kinds of services and solutions developed. And importantly, you develop a solution in city 1, it can work in any other city. it's all, the whole point is that it's like a standardized interface, and because it is supposed to be something which runs across all cities, it has to be open source and freely available and kind of really developed in a transparent way, and eventually kind of preventing vendor lock-in. So just to give you an example of what you could do with such a system, right? So let us take the example of responding to an emergency. There is this building, there are all these fire alarms put, and maybe every building puts fire alarms, and the fire department has access to the data from this fire alarms. We are in the world of IoT. The IoT sensors which are trying to detect smoke are connected to the servers in the fire department, because they are the first responders to fire. Data goes into the fire departments, and maybe there is an ICCC platform which is there. I'm sorry, the figures are a little small here, but let us say there is an ICCC platform out here which is taking data from the there's something just now from the in the bottom is the fire department, which is the one which has installed the sensors, and that data is getting into this kind of a common IoT platform. And then the traffic police is also I'll just go back. The traffic police is also connected to maybe a common IoT platform. Maybe it's a different platform, doesn't matter. And then you have the ambulance, multiple hospitals which are private entities, right? They might have their own IT and IoT system, maybe to keep track of their own ambulances, etc. Maybe they also have a way to connect with the emergency room. So let us say that the fire department is collecting data, and then it allows a third party to subscribe to that data. Let us say there is a startup which has developed this emergency response application which is sitting on the top, and that is getting data from each of these systems, and each of the owners of the systems have exposed certain kinds of data to be consumed, as well as exposed and taking commands or taking suggestions from the application. So now the emergency response application gets data from the fire department. The traffic police also accepts requests for green corridors from this application. So the idea is that you have this registration mechanism where all the entities or players are registered, and and then there is a separately offline they establish a trust, whatever it is, by payment or whatever it is they do it. The idea is that fire department knows whom it is giving data to, and similarly traffic police knows whom it is getting requests for green corridors from, and they kind of trust that, right, because they have separately set it up. And hospitals expose the ambulance location and accept ER requests, right? And this is where the smart emergency response app can coordinate a response to events in real time. Fire alarm, smoke alarm goes directly to this application, which does some analytics, figures out it's really important. It has some information about data, about where it's happening. It has access to Google Maps or whatever, and then it coordinates with the traffic to set up green corridors for fire trucks to go, ambulance to come in, sets up the ER, etc., right? So that is smartness. You are able to respond to live events using data and coordinating across multiple agencies to really, do the best you can, right? And the great thing is, if something like this can be done across a standard platform, I don't have to rewrite the code for a new city. Every city, you just download the app and you're good to go, right? And you work with the app developer and figure out the payments. So that is kind of our hope, that we can get to that kind of a system. So there are a few concepts, interesting concepts I thought I'll bring out in this particular platform. Now, by the way, this particular platform, we have been working also on this for the last 6 to 8 months, and we have reached a certain level of maturity in terms of the platform being developed, and it's actually running right now in Electronic City. I'll just kind of share that detail as we get to it. But one of the things we are actually one of the concepts here is the concept of a catalog of things. Everything has a presence in the platform. Now, certain things are smart things or internet-enabled things to which you can talk. That is the whole point of, if I have a chair, it's an asset. I just have an entry for the asset. But if I have a sensor in the chair which can detect, if someone is sitting or not, then it can send me a message as soon as someone sits. So then that becomes a smart thing. So the catalog actually, what it does is it captures static information about the thing, as well as the schemas of messages with which you can interact with the thing. And the thing is that, so once you have a device which is onboarded into the platform. That schema is there, and then you can kind of control. So the messages coming from that particular device or going to the device can then be validated against the schema. Excuse me. So you can kind of say the range of values is this much. I'll tell you how the schema looks. For example, here in the bottom left is an example of a schema. So this could be a schema of one of the messages. Excuse me. So for example, it could be a smart street light. One of the fields is lux output, and it says it's a field name is lux output. Its value is a number. There's some description. There's some units. This is up to the vendor. The vendor has to define this. An important thing here is we are also incorporating this concept of sharing level. You can share the message. It could be a public message. That means anyone can access that message. It can be a private message. That means only the owner of that data source gets the message. Or it can be protected. That means you need authorization from the owner to access that. So you have 3 different levels of sharing you can control on a per message basis, and messages get validated both going from the device to the application and from the application to the device. So essentially with this you can have a uniform way of looking at devices, whether they are whether they have an IP address or they are non-IP. For example, devices on a LoRa network don't have IP, so it doesn't matter. As far as the system goes, every entity has a unique ID, and then there are messages by which you interact. The second concept which we are proposing in this particular data exchange platform is to really support media data exchange. And the media data is just too heavy, right? And you'll have to have a few people come in and do the analytics on it. Like suppose I want to know the number of diesel vehicles coming per 15 minutes in a traffic junction, right? And so on. So there's one guy who does the analytics, or maybe there are 2-3 different competing vendors who do the analytics, but then they make all the data available to others to consume. So downstream people no longer have to work with the raw video stream. To support that, what we are saying is that when you have I'm sorry the fonts are a little small, I'll just explain out here. You have the raw video stream coming in. What we are saying is you have an annotation stream which works off the raw video stream, and it can spew out certain packets. For example, it could be this. Sorry, let me just get So this is a piece of packet which is referring to this piece of video data out here, and it has some semantic information about that video data, right? It could be the number of diesel vehicles, for example, right? And the idea is that there is a connection between, and there is a way you tag this particular data packet with this sequence or this subsequence of the video data. And that is used, for example, another application is, let us say you are collecting data from a mobile source like a drone. The drone is spewing out the video stream, but you would like to tag it with the location information, right? So that later on you can analyze that, because you have that this sequence of pictures or frames corresponds to this GPS location. So that is what we are actually kind of saying out here, a format by which you can kind of get that out. And we are exploring different ways of doing the tagging, because you need to kind of put a marker in the video sequence to say, okay, this sequence of GOP, or this sequence of frames has this ID. That ID then can be used in your data packet. And various ways we are looking at it. One way is, in the Edge.264, it has this notion of SEIs, in which you can actually insert an ID, unique ID, and then that you can use also to put in your data packet. So, for example, you can take a group of pictures and there is a SEI field in which you can put an ID. So, for that group of pictures, the particular data packet will make some comment on those group of pictures, right? And as I said, the data packet can contain additional semantic information, kind of saying something about the content of the video stream. And then with this, you can have this whole graph of analytics software running, where some use raw data, some use analyzed data. You can keep building and chain your analytics to use one feeding to the other. The third concept we want to kind of really also look at as we go forward in this kind of platform is to support edge analytics. And as an example, you have the devices which are usually put out in the field near the streets, maybe on poles, etc., like cameras and so on, connected to the main hub through these gateways. The blue things are the IoT gateways. Then you might have some kind of a broadband network, either optical or 4G or maybe 5G, well, not 5G but 4G, and then or it could be optical or Ethernet. And then you have a local data center or micro data center which is syncing the data, especially the video data. The other data can go off to the cloud, but video will probably be locally stored. So the IoT data, the gateways and the local, the fog node, the micro data center kind of form a local cloud in some sense. And the analytics you run on video has to run there. It can't be sitting in the cloud somewhere else. It will be running locally out there. And also from a privacy perspective, also the enterprise or the organization might not want to let data out of them. They might want to say, you give me your question, I'll answer it, I'll have it, run it in my enclave, and then I'll give you the answer. And I'll make sure the answer doesn't leak any information I don't want you to leak. And so this being able to run such analytics in a way where the analytics can run in the fog or the edge is very important. And there are a lot of other interesting research questions, in terms of being able to create this kind of distributed programming and runtime frameworks and so on. But this is something which in the future, hopefully the cities will also be able to support. The next concept I kind of want to bring out is this notion of context, right? When you have IoT data coming in, if you want to interpret, you want to know what is around it, just getting some raw numbers or even knowing that it's temperature or whatever. You want to know how to deal with that, and that context you want to capture, and and what we feel is that the graph structure is like it seems to be the best structure to be able to capture this concept. So for context, for example, imagine you have these regions of spaces. This piece of road SR1 is a road, SR2 is another space, and that is where there's a building. Microsoft Research, I've just labeled that, and then you have this connection of these spaces. SR1 is next to SR2, SR1 is next to SR3, and so on. You have a graph, right? And you have these, essentially you can think of each of these as entities, and you have relationships between entities, and those relationships are captured in graphs, and that is important. And just to kind of, and this entity has, again, some kind of description, and you might actually have some of these entities, as I described, could also be active entities to which you can communicate and so on. And now, if you imagine that you have sensors on a particular entity, like SR1 has a sensor, right? And it's a traffic video feed, and then you have analytics running, it detects an accident, right? Or something bad happens there. And your application the task is to notify all the people who might be affected by that. For you to be able to do that, you need to know the context. And that is where this kind of a graph database will help you to actually do your inferencing and kind of complete the solution to the problem. And finally, security, privacy, and monetization is something which has to be part of this particular framework. And and you have to kind of allow for different levels of security, low, medium, strong, because depending on the resource constraints, and the privacy has to be privacy by design. I already kind of mentioned the concept of sharing levels, protected, private, public, and also you want to kind of allow for tracking of your data as you go forward, who's using your data and so on. And we would like this to be integrated with the existing India stack, both the consent layer as well as the payments layer, so that you can build on what is already developed. So this activity which we are doing, we are actually we created kind of a pre-alpha version of this system, which along with a bunch of collaborators, and then we are kind of testing it out in Electronic City. So the small portion of Electronic City. So this is that portion where there's a fiber loop, and all these junctions have cameras. There are some air quality sensors, smart street lights, etc., etc. And we are working with a number of partners. LCTA, of course, is the Electronic City Township Authority, which is kindly agreed to give us a space to do this experiment, and working with Intel, Tejas Networks, Bosch, Dell, VMware, Icon, some startups, Icon, Sirpi are startups, and Wipro, and so on. So here, of course, we are looking at traffic monitoring, gray spot monitoring, street lights, citizen engagement as the applications. So this is work in progress, and what we are, what we believe is that this kind of data exchange is a really very important foundational layer, which will be needed to kind of have urban innovation happen for the next generation of smart city implementations. And it should be developed as a open platform with open APIs and data models, as well as open source. So from ISC, whatever we are doing, we'll make it open source. We call it open source reference implementation, because from ISC we have not really made products, so we'll say what we make is a reference implementation. If someone can take it up and productize and ruggedize, that's great, but that is what we are kind of promising. And the idea is that if you can have this two-phased approach where you have an R&D activity going on, which is trying out new ideas, new concepts, and then in a test bed of some kind, and then what works gets released as a production version in the real implementation. Because if you don't have that pipeline, you will not be able to try out new concepts, blockchains, how are they useful, how will you, are they useful, how will you use it, etc., right, as an example, right. So things like that, you need to kind of try it out first. And hopefully you can also make it future proof by interacting with a large innovation kind of R&D ecosystem, so that you can bring in new concepts in this. And it can't be done by a single institution, you need to have a consortium. So we are already, as I said, working with some companies in an informal way, but now we would like to formalize as we go forward. And I think engaging with IEEE will be very good for us for this whole activity, because there's a lot of expertise and wisdom out here. So with that, I come to the end. I would like to acknowledge the hard work of a number of people to at least get us to where we are. There is a small team in ISC, Robert Bosch Center, which has been doing a lot of the technical work. Electronic City has been a very friendly city to us. They are also very keen that their Electronic City becomes like the best smart city example, and they are very keen, and they have been kind of very open and allowed us to work with them. And as I mentioned, we have been working with a number of industry collaborators on this project. And finally, the Smart Cities mission from Ministry of Housing and Urban Affairs has now really embraced this concept of a data exchange. And